Okay, so when we looked at this, like we said that, okay, we've tried A, now we're gonna try letter B, and if you tried this at home already, that's great. If you haven't, we'll go through this together, okay? So let's see if we can, in this particular case, we have a point. We have a point, 3, -7. 3, -7. So let's see where that is. So +3, -7. What's that one? Now we could do this on a grid and actually physically plotting the point and then figuring out the angle. We could have totally done all that stuff, right? Plotting the point and then figuring out the angle. And when I meant figuring out the angle, meaning just taking a protractor and measuring it. But we're not gonna do that. We're at this particular stage in life that we could do these things algebraically, solving without measuring. So how can we do this?
Find the R.
It says here, determine the exact values for the 6 trig ratios. So the 6 trig ratios are sine, cosine, tangent, secant, cosecant, and cotangent. So let's do that. So what's the first thing that we have to do? Find out the hypotenuse. The hypotenuse is really the radius if there was a circle in here, right? Yeah, so go ahead and let's figure out the hypotenuse. Okay, so we've come to the conclusion that R is 58. It's called the hypotenuse or the radius if this happens to be a circle that way. So from here we can figure out the sine, cosine, tangent. Okay, let's start with the cos theta. What's a cos theta? Okay. It's adjacent over hypotenuse, so it's going to be 3 over root of 58. Sine theta, opposite, which is -7 over root of 58. Tan theta. Tan theta, we can go sine theta divided by cos theta, or we can say y over x. So it's going to be -7 over 3, yes? And then from here, the other are just reciprocal, so it's pretty straightforward. Okay, I think that's pretty good. So when you see that on the test, or an assignment, or provincial exam, that's how you would approach it, right? Now the next part of that says, determine to the nearest tenth of a radian the possible values of theta in that given domain. So we can, okay, we can use some of these information. So cos theta is equals to 3 over root of 58. So theta is cos inverse of 3 over root of 58.
radian.
Okay, yeah, I gotta be careful here because in this particular case, our angle has to be in radian. Radian, okay? So in our calculator, using my calculator, it says, should say radian. So cos inverse of 3 divided by square root 58 is 1.10th decimal. Okay, so 1.1, so 1.2 radians. Because they said 10th of a radian. I always have to go back and see what the one was, right? Well, this one here is the reference angle. That's a reference angle. Now, if this is 1.2 radian is reference angle, so that means this part here is 1.2 radians. So up here is 1.2. Yes? You okay? So if the angle is says pi or something radians, it has to be in radian mode. Sound good? Yeah. So from here, how can we figure it out from there? Yeah, so it's going to be our theta is going to be 2 pi, good, because we're operating in a radian mode, so 2 pi minus 1.2 so it's 5.1. Oh, how did we get 2 pi? When we look at the angle, so from here to here is pi, and then to go around is 2 pi. So if it's all the way around is 2 pi, but it's not all the way around, right? We said that this is going to be 1.2, so it's going to be 2 pi minus 1.2. So we know that it's just up to here. Okay, now if I go like this, I'm pretty sure you do remember this. If it's degrees, you go from 0, 180, 360, right? So if you know this angle here, your reference angle, from here to here would be 360 minus that. Yeah. Good? Yeah, it takes a while getting used to the pi radians, right? To pi. So 2 pi minus 1.2, so 5.1. So that's from here up to there. That's 5.1. Now you look at this one, we need to go as far as to 4 pi. So how many revolutions is that? How many rounds? Twice, right? Okay. So this is just one round. If we go another round and continue on for another one, that's a coterminal. That's going to be 5.1 plus another 2 pi times 1 more round. That's what coterminal does. So 5.1 plus 2 pi is going to give us 11.4 radians. Okay, is that good? So, can we go another round? We can't, right? Because here it's only 4 pi. 4 pi is 12.56, and this is going to be negative 12.56 radians. So if we go for another round, we're going to go over the 12.56.
Can we just subtract 4 pi by 1.2 to get that?
Yeah, we could do that too. Yeah. Yeah. But I'm using, yeah, that's another strategy. There could be like different strategies to visualize this, to think about it. Okay, so these are the positive angles. Now we're going to go to the negative angle. So our angle is 1.2. Okay, I'm going to need a piece of paper. This is going to be 1.2 radians, right? Yes, 1.2 radians. So we're over here already. And then now, instead of turning counterclockwise, because we're going to go to the negative angle, we're going to go to counterclockwise. So we're over here, and then we're going to turn around counterclockwise. So if we go around clockwise, okay, so this is counterclockwise. If we go clockwise, that's turning negative angle. That's going to be 1.2 plus 2 pi, and then we're turning the other way once. Okay, so our K is negative 1. Now if we do that, that's going to be, the other coterminal would be 1.2 plus 2 pi times negative 1. So it's going to give us negative 5.1 radians. Okay, can we do one more round? Another negative 2 pi. So now we're at 1.2 plus 2 pi times negative 2, because negative 2, that means we're going to go around twice. Let's try that. 1.2 plus 2 pi times negative 1. It's going to give us 1.2 plus 2 pi times negative 2, rather. Negative 11.4 radians. So 1.2 plus 2 pi times negative 2 is going to give us negative 11.4 radians. So we have four solutions for theta. 4 solutions for theta. So theta are 5.1 radians, 11.4 radians, negative 5.1 radians, and 11.4 radians.
We could have just did it the other way too, right? Where it's like negative 5.1 radian plus 2 pi times the negative 1. It's like a whole bunch of ways.
Yeah, there's a bunch of ways. Okay. Good. Now going back to these ones here. what angle is this pi over 4 in degrees?
Oh, 45.
45 degrees. So if this is pi over 4, then this is going to be root 2 over 2, root 2 over 2. So this is pi over 4. What would this be? Two pi over 4. But we know 2 pi over 4 is the same thing as a half pi over 2, right? What would this be? Yeah, so it's going to be 3 pi over 4. And what's the x and y values for those? Negative root 2 over 2 and positive root 2 over 2. Okay. So pi over 4, 2 pi over 4, 3 pi over 4. This one would be 4 pi over 4. And if we, of course, when we simplify that, that becomes just a pi, right? What would this be?
Negative root 2.
5 pi over 4. And the x is negative root 2 over 2. Negative, and then down, so it's another negative root 2 over 2. Okay, so what would this be? What angle is this? 6 pi over 4, and then if we simplify that 6 pi over 4, that's 3 pi halves. And then this one would be 7 pi over 4. And what's the coordinates there? Root 2 over 2, negative root 2 over 2. And then from here, what would this be? 8 pi over 4. And then 8 pi over 4, that's 2 pi. Okay, good. Now, I'll get you to fill this out on page 21 and page 22. Okay, so figure those out. Hello. You finished? Okay, you're good? Yeah. So when we actually put them together, we can do that over here on page 24, and certainly you can do this on your own. Now it says here, now with your teacher, I think you could do it on your own, right? Because you got the pi over 4 in here. Oh, sorry, no, pi over 6, pi over 4, pi over 3, pi 6, 2 pi 6, this is pi halves. This is going to be, if we count by pi over 6, this is going to be 4 pi over 6, which is 2/3. 2 pi over 3, 3 pi over 4. It's like fraction all over again, right? Two-thirds, 3/3, 4/3, 4/3, this is 5/3, and then 6/3. And then pi over 4s, 1/4, 2/4, 3/4, 4/4, 5 pi by 4, 6 pi by 4, which is the same thing as 9/6, which is the same thing as 3 pi halves. Okay. So 6/4, 7 pi over 4. And then your back here would be 8 pi over 4, which is always 2 pi. Is that good? And then from here you can write down your points, the coordinate of the points. What do you think this is? Pi over 6. 30 degrees. What's the coordinate? √3 over 2, comma, 1/2. And does that make sense? Because √3 over 2 is long, and then y is a half, because it's a half of the whole thing, right? Yeah, the same thing. Even though it's radius, yeah, the radius is still 1. The angle is just different in radians. Okay, so yesterday we went up to here. We'll get to do example 2 and example 3, and then we'll do example 4, 5 today. So example number 2, determine the exact values of the ratios shown below. Okay. So now when they say exact, oh, here, look at this. Pi over 3. Okay, do we have an exact value for that? Is that one of the special angles? Yeah, so if it's pi over 3, where is negative 7 pi over 3? So this is going to be 0, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, and then again here, -7. Is everybody okay? Because we're going clockwise here, so negative pi, -7 pi over 3 is there. So what's the exact, determine the exact values of that tangent. Well, what's the tangent of -7 pi over 3? Well, first of all, we have to figure out the coordinates. What's the coordinate for that one? It's gonna be 1/2 and then -3 over 2. Okay? So 1/2 and -3 over 2. So this one here is one of the special angles. Okay, let's go back in here. Okay. Actually, I'll go this way because it has everything already filled out. Okay, so if we go this way, okay, what does it say? By 3s. So this is 0. Okay. -1/3, -2/3, -3/3, -4/3, -5/3, -6/3, and then -7/3. I gotta go this way. So 1/2. This is the one that we want. 1/2 -3 over 2. Yeah. Is that okay? I'm sorry, I can't hear you properly. I can't hear it properly. Are you sure? Okay, here's the other thing that I can show you. -7 pi over 3. I'm going to do a long division in here. So -7 divided by 3. So that means I'm going to go -2 -7 divided by 3, that's -2. And I still have a -1/3 to go. So that means from 0, I go around you got a -1/3 to go from here. So if this is from 0, you have -1/3 to go this way. So pi over 3. Pi over 3, but it's this way, clockwise. Yeah. So, are we okay with this piece now? We got this number?
Just kind of put the numbers on the calculator, we find the exact value. Can we do that? Without doing the rotation.
Okay, here we go. We'll see if we put that onto your calculator. Let's try it in. Okay. What number did we get? I'm gonna get -1.73. Did you get that? Yeah? So the tangent is negative 1.73. Now this one here is not an exact value because it's a whole bunch of decimals.
It's irrational.
Yeah, it's going to be an irrational number. This is not exact, right? Every time you have negative 1.73 and a whole bunch of digits here, non-terminating, non-repeating, it's not exact. So how can we make the exact? Well, what's 10? 10 of negative 7 pi over 3, that's the same thing as y over x, right? Yes? Y over x, or sine theta divided by cos theta. Let's try that. So negative root 3 over 2 divided by 1/2. The 2 would cancel. You're left with negative root of 3. Negative root of 3. So I'm going to go here. Negative square root of 3. And they're the same value, right? Negative square root of 3. This is the exact. And then the approximate would be negative 1.73. They're asking for the exact value. The exact value is negative square root of 3. We can put that into our calculator, but our calculator will give us decimals. Okay, is that good? Now let's take a look at this one. (11 pi over 6). Well, let's figure out where's 11 pi over 6. It's quadrant 4. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 7, 6, 6, 6, 7, 6, 8, 6, 9, 10, 11. 11 sixths. So it's in quadrant 4. It's a special angle. Pi over 6 is a special angle. So what's the coordinate of that? It's going to be root of 2 over root 3 over 2, positive, and then down negative 1/2. So from here to there. Okay. Now this one is just the cos of theta. This one is sine of theta. We don't have secant of theta in this picture, right? This is cos theta, this is sine theta. Well, how can we figure out the secant of theta? Well, secant of theta is equals to the reciprocal of cos theta. So whatever the cos theta is, we're going to take the reciprocal of that. So that's equal to 2 root of 3. 2 root of 3. Okay, now how do you do that on your calculator? We don't have secant on our calculator. Okay, you're wondering about that, right? So how do you even check if our answer is kind of reasonable? So we have to go, okay, well, secant of, let's start with this one here. Cos theta is 3/2, or root of 3 over 2. So cos of theta is 3 over 2. Okay, so We don't have. Okay, cos of 11 pi over 6, like that. Cos of 11 pi over 6 is root 3 over 2, right? But we want the reciprocal of that. Look for, where is that? Do you have a key on your calculator? It says 1 over x.
Or x minus 1?
X minus 1. Do you have that?
Yeah. Or I have an x with an exclamation mark.
Oh no, not that one. That's a factorial. Here. I'm gonna, okay, look in your calculator. Look for x to the negative 1. X to the negative 1 is a reciprocal. Okay? So now you go second function. You don't have it? I guess I have to press equals. Oh, maybe it's not that one for me. So 2 divided by square root of 3. Did you press equals after? 1 over x?
Pi instead of root. You did 3 pi instead of root.
Oh, did I?
Yeah.
Okay. Yeah. So 2 divided by the square root of 3 is 1.15, right? So 2 divided by the square root of 3 is 1.15. Okay?
It says exact. So
But we want the exact. What we're trying to do is just to figure out if our answer is correct. Okay? The exact should be 2 root of 3. 2 root of 3. Now, let's take a look at example number 3. It says here, determine the value of the ratio shown below to 3 decimal places. Now, if you notice here, they said 3 decimal places. Why didn't they say exact?
Because they want us to make an approximate.
Yeah, that's a good thing, yeah. Okay,
and they're not
anything
special
else?
angles?
And they're not special angles, right? Because here, we can simplify this. This is cos of 3 and 5, that becomes the same thing as pi over 5. And pi over 5 is not a special angle. Okay, not a special angle. The only way we can get an exact is if we have a special angle. This one is not. So, this one, just type it in the way you see it. Now the thing that I have to do is I have to make sure that I'm putting everything inside the brackets. Okay, I'll show you an answer where I don't put it inside the brackets. And tell me why it's wrong. So this is inside the brackets. This is outside the brackets. If I go like this, cos 3 pi divided by 15. That's right. It does the order of operation. It takes the cos of 3 pi, whatever that 3 pi is, the answer, it got divided now by 15 rather. Okay, so you have to make sure you put a brackets. So we are taking the cos of everything there. Now this one, this is an issue because we can't just type it into our calculator, right? So, but we know an identity, cosecant theta is the same thing as 1 over sine of negative 2 pi over 3. Okay, so if we could just figure out this and then take the reciprocal of that, then we'll figure it out. Is that okay? 2 pi over 7. Where did I get the 2 and the 3?
Friday.
That's what I say. Okay, so let's figure this out first. So sine of brackets negative 2 pi divided by 7. It's going to give me a negative 0.78, right? Then I can go 1 over negative 0.781, 818. So I take 1 divided by my answer is negative 1.279.
Couldn't we easily just type it out?
Mm-hmm. Oh yeah, we could easily type it in all at once. Yeah. You can go 1 divided by sine of negative 2 pi divided by 7. Yeah, that's true. I could do that. Get the same thing? Yeah. I could do everything all at once.
We sure we're a calculator.
Yeah. Okay. So this is in 3 decimal places because pi over 7 is not a special angle. Take a look at this one. Determine the exact values of theta in the domain of 0, between 0 and 2 pi. Now this is when we have to go and say, okay, where is sine a half? Where is sine a half? So unit circle, sine, that means the y value is a half.
30?
Mm-hmm. That's degrees. We're thinking 30 degrees, right? 30 degrees. So, but what would that be in theta? Being radian.
Give me quadrants 1 and 2. Or
1 and 2.
Yeah, quadrant 1 and 2. So we have 2 angles that will give us a sine of a half. That's going to give us pi over 6, right? That's pi over 6. And then the other one would be 5 pi over 6. Okay. Let's check it. See if our answer is reasonable. Go sine of pi over 6. You got 0.5? Yeah? Okay, now let's try the other one. Sine of 5 pi over 6. Yeah. And that's only between 0 and 2 pi. So 0 and 2 pi. Those are the only two. Okay. Now let's try this one. Where is cos negative?
everywhere but, no, sorry, 2 and 3.
Cos is negative in quadrant 2 and quadrant 3. So here. It's negative root 3 over 2, so that's going to be like a little bit further. Right? This is negative. So what angle would that be in?
Same as the last.
This is 5 pi over 6. 5 pi over 6. And then the other one would be 7 pi over 6. Is that okay? Now try it. Let's try it. We gotta test it. See if it makes sense to us. Cos of 5 pi divided by 6. It's negative 0.866. Yeah, that works. So that one is good. Now try this one. Cos of 7 pi over 6. It's also negative 0.866. But then this is exact values of pi of the angle. Could you have used your calculator to figure it out? Any other possibilities? Any other ideas on how you can solve for theta? How do we solve for theta? Inverse. So we can go cos inverse of negative root 3 over 2. Well, they give us an exact value.
One-sixth pi.
It's going to give me 2.6 radians. Well, what's 2.6 radians? 2.617 radians. This is approximate. But if we go 5 pi over 6, 5 pi divided by 6. So this is exact, this is approximate. Are you convinced? Okay. Are you convinced or no?
I'm convinced I don't like radians.
You can. Oh, here.
But I want to learn about
Yeah.
torque, so I better start liking it.
Yeah. Okay. Let's try this one. Last one. Where's tangent 1? Tangent of theta is equal to 1. Okay. It would be quadrant 1 and quadrant 3. And that angle is 45 degrees. Oh, why did I say degrees? Yeah, it is 45 degrees.
Said the D word.
Yeah. Okay, so what's the angle? 45 degrees, that's pi over 4, and 5 pi over 4. Okay. Let's try these, example 5. Now they're using something that's exact values, okay? If they want exact values, but this time, the angle is not from 0 to 2 pi, it's going to be from negative 2 pi to 2 pi. Negative 2 pi to 2 pi. Okay, so let's see here. Secant of theta is equal to 2. What do we know about secant theta? It's going to be 1. Secant theta is 2, so that means cos theta is the reciprocal of this, a half. Where is cos a half? Okay, cos is the x value, a half is here, so a half there, a half there. Cos is positive in quadrants 1 and 4. So what angles are they? So this is 60, that's degrees though, okay, yeah.
So what do we say?
Pi
So
over.
that's going to be pi over 3. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3.
So different when you ask for angle.
Yeah. Take a look at this one. Cotangent. So that means if we were to do tangent, we have to take the reciprocal of that, which is still negative 1. So where is tangent negative? Quadrant 2 and quadrant 2 and 4. 2 and 4. Tangent is negative in 2 and 4. And it's negative 1. So that means that's... Okay, it's okay. How about this? You think about degrees, and then now change that degree into radian. Would that help a little bit? Yes. Okay, so you know that this is going to be 45 degrees. So that means a pi over 4, pi over 4, 2 pi over 4, 3 pi over 4. So theta is 3 pi over 4. And this is going to be 7 pi over 4. Does that help a little bit? Yeah, okay, good.
Much better.
Much better. Okay, good. I'm glad we have some kind of a solution. Sine is 0. Where is sine 0? Sine is 0 means y is...
Oh, can we say degrees?
Yeah, say the degrees.
It's like a half pi?
0, 180, 360. So now, if it's 0, then that means 0 radians, pi radians, or just pi, and then 2 pi. Now I gotta go back in here because I forgot that we have to go to negative as well. Yeah.
So do we just make those negative as well?
So we're gonna make this a negative. Cos is a half. So these are the angles in a positive direction. Now we're going to go to the negative direction. So that's going to be from here to here is negative pi over 3. Okay, so we're going to go back because I totally forgot the negative angles. And then the other one is from here all the way to there is going to be negative 5 pi over 3. What about this one? We're gonna go this piece. So now this is gonna be negative pi over 4. And that's gonna be negative 5 pi over 4. Yes? And this one here, we're gonna go to the negative part, negative angle. So 0 is already there. Negative pi, and then all the way around negative 2 pi. Oh. So there are 5 solutions for letter C. Letter C. It said, number 6. To the nearest tenth of a radian, determine the possible values of theta in the domain between 0 to 2 pi. So we want all the angles between 0 and 2 pi, all of our answers. Now, why did they say tenth of a radian? It's not the exact value because they're not special angles, right? Okay, so here, theta. Where's theta positive? Quadrant 1 and quadrant 4. Okay, so cos inverse of 0.85 nearest tenth, so I'm just going to go 0.6 radians. Okay. So our reference angle is 0.6 radians and another 0.6 radians. So in quadrant 4, it's going to be 2 pi minus 0.6. It's like 5.7. So from here to here, that's 1, and then from here to here, that's 2. 2 solutions. Let's try this one, cotangent. Oh. We can't take the cos inverse of cotangent, so what can we do? Figure out the tan. Tan would be negative 5 over 2. Now, negative 1.2 radian, where is that? We've got to ask ourselves, where is tan negative?
2 and 4.
Quadrant 2 and quadrant 4. So this one is our reference angle, right? Our reference angle. So in quadrant 2, then that would be pi minus 1.2. Yes? So pi minus 1.2. So it's 1.9 radians. And then what about the one on, that's not quadrant 4. Quadrant 4 is right here. That would be in quadrant 4, would be 2 pi minus 1.2. So 5.1. Is that okay?
To get to 5.1, you just took the 2 pi?
Mm-hmm. Yeah. So if you go all the way around, that's 2 pi, but then we don't go all the way to 2 pi because we have the 1.2 here. Gotta subtract the 1.2. Okay. Last but not the least. Any ideas on how we can approach example 7? Any ideas?
You know that prime fraction. Yeah. Sine.
Reciprocal, right? We gotta take the reciprocal because we don't have this in our calculator. Yes. So this is gonna be, sine theta is gonna be 1 over 3.7. So if you go theta, it's gonna be the sine inverse of 1 over 3.7. Now I gotta ask ourselves, where is sine positive? Quadrant, sine is positive in quadrants 1 and 2. Okay, so that's a reference angle right there. We know it's going to be quadrants 1 and 2. So this one would be in quadrant 1. Did I say, oh yes it is, you're right, because it's 10th. 0.3. So what would it be in quadrant 2? Pi minus 0.3. Good, 2.8. Okay, so that makes it to the positive up to 2 pi. What about the negative 2 pi? So from here all the way down there would be
Pi plus.
pi plus
0.3.
0.3, 3.4 radians, but it's negative, right? Because it's going this way. And then we go from here to here. It's going to give us 0.3. It's going to be 2 pi minus 0.3. It's going to be 5.98 or negative 6 radians. Okay. Last but not the least. I can see that this definitely need a practice, and then some of these questions definitely have some practice. Let's try this. Sine of negative 5/9. Where is sine negative?
Where is the negative?
3 and 4. Three and 4. So sine theta is equals to negative 5/9. So theta is equal to okay. So our reference angle would be 0.6 0.6 radians. So 0.6 here, 0.6 there. So let's talk about the positive angle first. So from here to there is going to be pi plus 0.6, yes. Yeah, it is. Actually, it is exactly like that. But instead of 180 plus, it's going to be pi plus. And then what would this other one be? 2 pi minus 0.6. Yeah. So 5.7. Yeah. So that's the positive angle. Now we're going to go negative angle. So from here to here. So from here to here, that's a negative angle. That's negative 0.6. Negative 0.6. And then from here to here. So it's pi minus 0.6, but it's a negative, right? So it's going to be 2.5. Radians.
So wait, if we're going negative, should I just...
Yeah, so we go from here to here. Yeah. So from here, if we're going to go this way, negative 2.5. So we go from here to here, from here to there, and then from here to here, from here to there. Okay. Okay, so that's good. We have some time to do work. Let me see.